I want you to imagine that you live in a town and you were sitting at home one day when all of a sudden tornado sirens go off in your area. You do not have access to a tornado shelter. What would you do? According to the Bulletin of the American Meteorological Society, on average 1,200 tornadoes are reported in the United States each year. Every person, regardless of where they live in the United States, should be knowledgeable, at least briefly, about tornadoes and should know how to react safely in multiple situations. If you are not able to answer what you would do in the previously stated scenario, then be encouraged that by the end of this speech, you will be more knowledgeable about tornadoes and you will be aware of different methods to prepare for tornadoes and how to take shelter. As an atmospheric science major who is interested in tornadoes my entire life and has gained much knowledge from past and recent research, I would like to inform you on how tornadoes form, how they can be detected on radar, how they are rated using the EF scale, and how you can prepare for tornadoes and take shelter in a variety of situations. Tornadoes, especially the strongest tornadoes, are usually formed from a supercell. Supercell is a thunderstorm with a rotating updraft known as a mesocyclone. There are 4 ingredients needed for a supercell to form. The first of these ingredients is an unstable atmosphere. Instability is how likely the atmosphere is on any given day to allow an air parcel to rise into the atmosphere. Second of all, we need moisture. A moist atmosphere is needed for evaporation to take place and clouds to form. Third of all, we need a lifting mechanism of some kind. In the case of most severe weather, this lifting mechanism is a cold front moving into an area that forces warm, moist air ahead of it up into the atmosphere, and this warm air being lifted up rapidly is known as the updraft. Last of all, for severe thunderstorm to occur, we need strong wind shear. Wind shear is the difference in wind speed and direction as you go up in the atmosphere. According to Markowski, a difference of roughly 50 miles per hour between the surface wind and winds at 18,000 feet is typically sufficient to create supercells. With this strong difference in wind speed and direction with height, a rotating column of air horizontally at the surface is formed, and the updraft of the storm pushes this up vertically, and this rotating updraft is known as the mesocyclone. Once a mesocyclone is formed, tornadoes are able to be produced from this rotation. Doppler radar can be used to detect tornadoes, and the EF scale is used to rate tornadoes after they have occurred. Reflectivity is the radar the meteorologists use on the Weather Channel, especially in cases of severe weather. There are several different indicators on radar that meteorologists look for in order to determine if a tornado is likely to occur. One of these radar indications is a squall line, which is a line of thunderstorms that move all together. Squall lines are able to produce very quick and unexpected tornadoes. Another radar indication is a supercell that we have discussed previously. Supercell is made up of a forward flank downdraft, a rear flank downdraft, and an updraft, and is shaped similar to this picture right here on a radar image. Next is a hook echo. That is a strong indication that a tornado is imminent to happen or is already on the ground. If you see a hook echo on a radar headed towards your area, you should take shelter immediately. According to the NOAA National Severe Storm Laboratory, a hook echo describes a pattern in radar reflectivity images that looks like a hook extending from the radar echo, usually in the right rear part of the storm, relative to the motion of the storm. A hook echo is an indicator of where the mesocyclone is located in the storm, and you can often see that rotation on radar images. The EF scale was created in order to replace the original Fujita scale that was created by Tetsuya Fujita. The EF scale is used to rate tornado strength based on the damage that they leave behind. According to Edwards, surveyors apply the EF scale by matching the observed damage structure to the appropriate damage indicator and then selecting the closest degree of damage. Surveyors go out on the field after a tornado has taken place and they view the different damage indicators, such as a concrete structure or a tree, and they look at the different degrees of damage that go with each damage indicator and determine what wind speeds could have led to the damage caused to these structures. Each wind speed range is associated with the EF rating that is given to a tornado, ranging from EF0 to EF5. Many lives are lost from people not knowing how to react to tornadoes and how to be prepared for them. According to the Bulletin of the American Meteorological Society, if an immediate tornado threat is determined either through warnings or observation, the safest place is a specially built tornado shelter. A tornado safe room or a basement in a home are also two other great options if you do not have access to a tornado shelter. However, tornadoes take place at any time in any location, and you may be caught without one of these three options to take shelter in. In that case, let's look at some other situations you might find yourself in. If you are in an area without a tornado shelter accessible to you and a tornado is coming, then the best thing to do is to go to the innermost room of that building, far away from windows as possible, and get down in the tornado safe position, crouch down with your head between your knees and your arms covering your head. If this is a multiple story building, make sure you only take shelter on the first floor. If you are caught outdoors and a tornado is headed for your area, take shelter immediately in the nearest building, or if there are no buildings, go to the lowest lying area such as a ditch and lie flat covering your head. If you are caught on the road driving, such as on a highway, and a tornado is headed towards your location, then you should evacuate immediately into a building or go to the lowest lying area if there are no buildings nearby. If you see an overpass near you and a tornado is coming, do not in any situation ever take shelter over or underneath an overpass, because they cause a wind tunneling effect that increases wind speed and will have debris flying at rapid speeds through the air, which can kill you. If you want to be prepared for tornadoes before they take place, there are a few methods you can try. First of all, have a tornado shelter or tornado safe room installed into your home. Second of all, be checking the weather regularly and every day if possible to know when you can expect severe weather for your area. Last of all, make sure you have access to get notifications, whether on a phone, radio, or TV. In conclusion, tornadoes are an amazing yet destructive and deadly phenomenon of nature that you should take very seriously. To recap what we've discussed in this speech, I have informed you of tornadogenesis and how it can be seen with radar, how tornadoes are rated using the EF scale, and what steps you can take to prepare for tornadoes and to take shelter wherever you are at. My hope is that from this speech you are now much more knowledgeable about tornadoes and that you know how to be as safe as possible in any given situation. I encourage you to go and share this information along with the tornado safety tips with those who might not be aware, so that no more lives are lost in tornadoes just because someone does not know how to react safely. Thank you.